All right, here we go. We're going to talk about parent graphs today. There are lots of parent graphs, but we kind of, as Algebra 1 teachers, have talked about which ones we're going to cover. There's a lot of information that I could talk about with parent graphs, but this is just, remember, this is day one of these functions. Not all of them are functions, but this is day one of this, and so the information that I give you is very specific. You need to be writing this down in your notes. You need to be able to identify paragraphs. That would be one of your learning targets. You need to be able to tell me some stuff about each one of these parent graphs. You need to know the name of each one of these parent graphs. Okay? Now, you may be saying, what is a parent graph, right? You have parents, two parents. Those two parents produced you. A mother and a father produced you. Parent graphs produce other graphs, right? Other graphs are derivatives of parent graphs. You may not exactly understand what that means, but it's okay. Parent graphs, are the original, the OG graphs, okay? So, the very first one is linear. Okay, linear, the root word is line. It's simply y equals x. Okay, y equals x will always produce a linear graph. Linear, the root word is line, meaning the graph is always going to be a straight line. If we do a simple t-chart, which we're going to do on each one of these, okay, if we do a simple t-chart on y equals x, right? Simple t-charts are usually numbers around the origin. What is the origin?
0, 0.
0, 0. So if I ask you to come up with a simple t-chart, or I give you a simple t-chart, you, in turn, should be able to complete the t-chart, and you should be able to identify. Okay, so linear, y equals x. Remember, the exponent is just to the first power. Okay, we don't write it when it's to the first power, but it's understood to be to the first power. So very simply, when I plug in -2 right here, what is my output? -2. Right? It's the easiest graph in the world. Y equals x. Whatever this value is going to be the same. They are equal. So instantly, I can recognize that t-chart. I can make that t-chart. I could use that t-chart to then graph the line. Right? -2 is right here. -1 is right here. 0, 0 is right here. 1, 1 is right here. +2 is right here. If I connect all those points, I get what's supposed to be a straight line. Give me another point on that line, way out in the distance somewhere. What would be another point on that line? How about 10, 10? Is that on the line? How about 100, 100? Is that on that line? How about -500, -500? Is that on the line?
Yes.
Sure it is. As long as the x and the y are equal, it's on this line, right? I was kind of joking, but that's bad, right? It was supposed to be right there. So this all goes together. Linear, and it looks like this. Okay? This graph looks like this. This is linear. Right? All of these things go together. If I tell you this, you need to understand that it's going to look something like this. It doesn't have to look exactly like this if it's linear, but it's a straight line. If I show you the graph, you should be able to back up and say y equals x. If I say y equals x, what is kind of the name of that? You would say, that's linear. Okay? The last thing I need to talk about is domain and range. Right, I'm going to do that for each one of these parent graphs, and you may not understand it completely right now, but you will. You should be writing this down. Okay? These are notes. Do you have a pencil? Okay. Domain and range. Domain are the x values, range are the y values. What does it mean when I say, what is the domain of this function? What is the range of this function? Well, we're going to learn that over the next couple days. And what I'm asking is, what values are allowed and or what values are not allowed? Okay? And we're going to write them in a particular way. Okay? In this case, what are the domain? Well, the domain are the x values. Don't forget that that's the x-axis. The graph essentially goes in this direction forever, and it goes in this direction forever. So we simply say that the domain is all real numbers. That's the symbol, an R with 2 bars. That is the symbol for all real numbers. That means from negative infinity all the way to positive infinity. Another way of writing all real numbers is simply to say negative infinity to positive infinity. And I use parentheses. Why? Because infinity can't be captured, right? That's not a hard point. Infinity technically is a concept, right? You can't put your finger on infinity. You can't put infinity in your calculator. Okay? So we're saying that this graph, here it is on Desmos, it goes in this direction forever, and it goes in this direction forever. That's on the x-axis. All right, how about the range? What are the range values? Those are the y values. Okay, that's your output, that's your y values. That's up and down. So look at the graph and tell me, does it go up forever?
Yes.
Yes. Does it go down forever?
Yes.
Are there any values that are not included? No. So it's all real numbers, and it goes from negative infinity to positive infinity. This is the easiest parent graph. We start off with the easiest. Okay, questions? Any questions on linear? Any questions on linear? Okay, draw a line. We're going to do the next one. How many are there? How many parent graphs are there? I think there's 6 more. So we did 1. How many we got to go? We got 1, 2, 3, 4, 5, 6 more. We got 6 more. There's 7 total. 7 total. All right, here we go. Y equals x squared. What is the name of this parent graph? Anytime the exponent is to the second power, we call this a quadratic. It's one of the main topics in Algebra 1. Right? We'll spend like a month, maybe 6 weeks, maybe 2 months in the spring talking about quadratics. Graphing them, factoring them, solving them, all kinds of stuff. Quadratic is a main topic. Okay? A t-chart of y equals x squared, right? Always like to do a very simple t-chart with these values. If I take -2 and I plug that into the function, right? This is a function. If I take -2 and I put it right here, remember that's y equals -2 squared, which is the same as -2 times -2, which is the same as +4. So if I take -2 and I plug it in there, I get +4. Okay? How about -1? What happens when I take -1 and I square it? I get +1. How about when I plug in 0? I get 0. When I plug in 1, what do I get? 1. When I plug in 2, what do I get? I get 4. And so on and so on. Okay? If I plug in 5, Mason, how many would I get? 25. Okay? Here's the graph. Right? We call this a quadratic. I'm going to graph it over here. So it's on the video. -2, 4, right there. 1, 1, 0, 0, +1, +1, and then +2, +4. I think I said that wrong. This point here is -1, 1, and this one is +1, 1. So it has a nice curve to it. Okay, it comes down, 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 right? It's up here, all the way at positive infinity. It comes down, 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 and it hits zero. It hits zero, and then what does it do? It turns and it goes up, 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 up forever. Okay? So we say a parabola, right? Write that down. Spelled like parabola. A parabola is the name of this graph. A parabola is nice and curved, and it points up. Now, I can point it down, right? If I change A to be a negative, it points down, but we'll get there. That's down the road. Okay? So, y equals x squared is called a quadratic. The graph of it is called a parabola. We have a very simple t-chart here, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. You need to memorize this t-chart goes with y equals x squared. It goes with being a quadratic. And then lastly, you need to memorize what the graph looks like. Here's Desmos right here, a nice, pretty graph. Y equals x squared. All right, questions on quadratic. 2 parent graphs down, how many to go? How many we got left? 5 to go. 5 to go. We got 7 total. All right. Is this better than a packet?
Yes.
Huh?
Yes.
Kind of. Well, the half year's got to fill in the blanks.
You like fill in the blank, huh?
Yes.
All right. Y equals the square root of x. Square root. You need to know that this is called square root. When you see y equals the square root of x, you think the name of that is square root. Okay? Here's a very simple t-chart. XY, negative 2, negative 1, 0, 1. I'm going to put 2, but we'll put 4 as well. Okay? When I plug in negative 2, what do I get? Everybody do it on your calculator. What is the square root of negative 2? You know how to do square root on your calculator? All right, so look on your Cassia.
Square root of what?
Negative 2. We're doing the t-chart. On square root of negative 2. Enter. What happens?
Error.
Yeah.
Why? Why do you get an error? Because you can't take the square root of a negative number, right? Unless you're talking imaginary numbers, you can't take the square root of a negative number. So this does not exist. However you want to write that, this is not possible. Not possible. In the real number system, this is not possible. Okay? Yep. All right, how about negative 1? What is the square root of negative 1? It's not possible. Okay? So I'm just going to do this as kind of no solution. Just I'm saying this is not possible and that is not possible. All right, wow. Well, that's kind of weird. Let's get to something that is possible. How about the square root of 0? 0. Yay. So if I'm plotting, I got a point. Yay. All right, how about the square root of 1?
1.
I got another point. 1, 1. All right, how about the square root of 2?
4.
No, careful. The square root of 2 is not 4 and it's not 2. Type it in. The square root of 2. Okay, hit the S to D button and change it to a decimal. 1 point what? 1.41. It's some decimal, right? I don't really want to use decimals. That's why I put 4 on here. What is the square root of 4? 2. So 1, 2, 3, 4 at 2. So my graph looks like this. If I do it on Desmos, and I get a much prettier graph right here, this is what the graph looks like. Can you see that?
Yeah.
Copy it down in your notes. So you need to know that this goes with this, and this goes with this, and this goes with this T-chart. This T-chart gives you this graph. This graph is called the square root graph. This graph is made of the parent function y equals the square root of x. All of those things are interconnected. I almost feel like I should make you do flashcards for Friday.
No.
Mandatory flashcards.
No.
The vocabulary?
What's wrong? Not right now. Okay. Questions? Any questions on this parent graph? Okay. All right, what's the next one? It's on the board here. Can you see it?
Y equals absolute value of x.
Uh-huh. What do you think it's called? Y absolute value. Y equals the absolute value of x is called
Absolute value.
absolute value. The absolute value. Who could tell me what the definition of absolute value is?
It's a positive on any number.
Wrong.
Positive value of every number.
Yep.
Distance it is away from zero.
Yay! That's the definition. Say it again for the people in the back.
The number is away from zero.
The distance that it is from zero, right? And distance can't be negative, right? Even if I drove my truck in reverse all the way to Savannah, it would still be 55 miles away. Distance is always positive. Write that down. Distance is always positive. So the absolute value of x is always a positive value. Distance can't be negative. So a very simple T-chart, right? -1 or -2, -1, 0, 1, and 2. Okay? Find each one of those now at your desk. Fill that in. It should be that quick, right? You know what absolute value is. It's not a mystery. Then graph it at your desk. Make a very simple graph. What does the absolute value function look like? You should know what it looks like. You should kind of know the definition of it. You should know what the T-chart looks like. You should be able to do a quick T-chart. You should be able to graph it. If I give you the graph, you should be able to say, oh, that's absolute value. Oh, it looks like this. And then last but not least, you should be able to tell me the domain and range. Did we do domain and range on the last one?
No,
I
that's
think
all.
we skipped it, didn't we?
Yeah, that was.
We did it on the first one, but then y equals x squared, I skipped it.
Yep, and then y equals.
We'll do it after this one. That was my fault. We'll come back. All right, here we go. -2, I take the absolute value of it, what do I get? 2. -1, take the absolute value, I get 1. 0, 1, 2. So -2 gives me +2. -1 gives me +1. 0, 0, 1, 1, and 2, 2. So instead of the quadratic that has a nice curve to it, this is a V. It's hard V. It comes down actually at a 90-degree angle. Okay? The absolute value of x function is graphed like that. Look at it over here. There we go. See it on there? All right. Last question. What is the domain and what is the range? The domain is all real numbers. Why? Well, it goes in this direction forever, and it goes in this direction forever. Never stops, never stops. It has no values that are not included. But what about the range? The range are your y values. Well, all of these values are included, but none of these values are included. There are no points in quadrants 3 and 4. So how do we say that? Well, the question is 0, 0 included? Is 0, 0 included in the graph? If it is, then we got to do a bracket and we say 0, meaning the graph starts at 0. And then it goes up and 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 up all the way to positive infinity. And then do we do a bracket or do we do a parenthesis?
Bracket.
We do a parenthesis. And that's okay. Today's day 1. But we always do a parenthesis with infinity. Why? Because you can't have a hard bracket on infinity. Like you can't say infinity. I can't bring a bucket of infinity money in here, right? You can't go to the beach and fill up a bucket of sand with infinity grains of sand on it, right? Because just as soon as you felt like you were there, I could add another shovel full, right? Infinity is a concept, okay? It's difficult to put you can't have infinity dollars in your checking account. Question?
What's the difference between, not the difference, but it's like the same thing.
They're similar, but they're not the same. Look at the T-charts, right? When I put in 2 into y equals x squared, I get 4.
Right.
When I put in 3, I get 9. When I put in 4, I get 16. On absolute value, when I put in 4, I get 4. Okay? Here, I'll lay one over the top of the other. Look at this. Look how different they are. Okay? They're quite a bit different. And kind of answering your question a little better, parabola is growing faster, quicker. So even right here, right, at 5, I'm already at 25. But on this one at 5, I'm only at 5. That make sense? Okay. I love decimals. All right, let's go back to square root because I messed up and skipped domain and range. But maybe it'll work out because now you understand brackets and parentheses. So let's go back to square root and on your notes there and talk about y equals the square root of x. What's the domain and what's the range? Remember, the graph looks like this. Didn't I do this one?
Mm-hmm.
Okay. So the graph looks like this. What's the domain? Is it all real numbers?
No.
No, it's not. Very good. What is the domain on this one? It starts at 0,
Bracket.
right? And it goes in that direction forever and ever and ever. So how do I do that?
Bracket.
Heart bracket 0.
Uh-huh.
And
Comma,
positive
infinity, parentheses.
Perfect. I love it. Maybe I should have done it in that order.
You didn't do it.
I'll do that for third block. I'll do quadratic, then I'll do absolute value, and then square root. So what I need to do is, how do I move this up? Will it let me? Oh, look, no, I didn't want it that high. Look at that. There we go. All right, how about range? What is the range on this problem? Is it all real numbers?
It's the
There's
same
no
thing.
values down here, so it can't be all real
The
numbers.
same thing as the domain.
Correct. Very good, Azari. Very good. It goes from 0 up and up, all the way to infinity. All right, I'm going to stop the video here. This is part A. Part B, we'll have the rest of the parent graphs.